All right, so any questions before we start? Okay. We're going to talk about differential equations today. This is class 5, section 6.3. A differential equation is an equation that has derivatives in it. So a simple example would be a satellite has constant velocity of 80 meters per second. If you let s of t represent the position of the satellite at time t, then we could write ds dt equals 80, because velocity is the derivative of position. So we could write ds dt equals 80. This is a simple differential equation. It's an equation that has a derivative in it. So what would a solution to this differential equation look like? What kind of function has as its derivative 80? A linear function, yeah. So this would be 80t plus c, right? So if ds dt is 80, then the solution of this differential equation is the function s of t equals 80t plus c. So the solution to a differential equation is a function as opposed to a number, right? So all the equations you've solved in your life, the solutions were numbers. Now, when we solve differential equations, they're equations that involve derivatives, and the solution is a function that makes the differential equation true. Okay, so differential equations can get much more complex. For example, y double prime minus y prime minus 12y equals 0. So if I'm trying to solve this equation, I'm looking for a function y, right? So my function y is the solution. So I want a function y so that when I take its second derivative and subtract its first derivative and then subtract 12 times itself, I get 0. Okay. Any thoughts on what kind of function I should be, like what family of functions should I be searching in here? But why do you think quadratics? Yeah, okay, I have to be able to take two derivatives. Yeah, so a quadratic, when I take the second derivative, I'd get a constant, right? So let's just do, for example, you know, a complete guess. Y equals x squared. Let's check if that's a solution. So y prime would be 2x, and y double prime is 2. So let's plug in y double prime minus y prime minus 12y equals 0. Y double prime is 2. Y prime is 2x minus 12 times y, and y is x squared. Does that equal 0? Always for any x? No, this is not true for all x's. Right? There might be an x that makes that true, but I'm looking for a function that makes that equation always true. So do you think a quadratic's going to work? Maybe a cubic? Sure. Let's check. Okay, so that means that y prime would be 3x squared. Y double prime is 6x. So when I plug into my equation, y double prime would be 6x minus y prime, which is 3x squared, minus 12 times y, and y is x cubed. Does that equal 0 for all x's? In order to add three terms together and have them equal 0, what has to be true about the three terms? Yeah, they got to cancel each other out somehow. So the reason these three can't cancel each other out is because x and x squared and x cubed are They're all different powers. They're not like terms. I can't add them together, right? So any polynomial is not going to work because it's going to give me 3 terms that can't be added together. Okay, so the polynomials aren't going to work. So that doesn't work. That doesn't work. What other kind of function could we try? Maybe something that when we take its derivative continuously, we keep getting the same kind of thing. Y equals 0, that's a good one. Right? So then y prime is 0 and y double prime is 0. So when I write down my equation and I plug in y double prime 0 minus y prime 0 minus 12 times 0. Is that true? Yeah. 0 equals 0, check. So y equals 0 is a solution. We call that the trivial solution. Yeah. There's another one. What about an e to the x? That's a good guess. So y prime, e to the x, y double prime is e to the x. So I have e to the x minus e to the x minus 12 e to the x. Does that equal 0? No. Yeah, I get negative 12 e to the x doesn't equal 0. But I'm on the right track because I have 3 terms that at least can all be added together. And I just need to manipulate, somehow make the coefficients come out right, so that when I add those 3 terms together, I get 0 e to the x's. So I'm only off by the coefficients in front. So I'm just going to give you a solution. I want you to verify that it makes that equation true. All right, so to check this solution, I need to be able to plug in y double prime and y prime and y. Okay, so I've given y, so I have to figure out what y prime and y double prime are. So if y is e to the 4x, what's y prime? Yeah, 4e to the 4x. The derivative of e to some stuff is e to the stuff times the derivative of the stuff, right? The derivative of 4x is 4. All right, and then we have to take the derivative again, y double prime. The derivative of e to some stuff is e to the stuff, right? So e to the 4x is going to be e to the 4x. This 4 comes along for the ride. It's still here. And then I have to multiply by the derivative of the stuff, which is 4 again. So this ends up being a 16. Everybody should be okay with that, right? Okay. Now when I plug in my y prime and my y double prime and my y into this equation, I get 16 e to the 4x minus 4 e to the 4x minus 12 e to the 4x, right? Because the 12 is this coefficient from the equation, and y is just e to the 4x. Okay. Does that equal 0? Well, 16 e to the 4x minus 4 e to the 4x, that's 12 e to the 4x, which is 0. So that means that e to the 4x is in fact a solution to this differential equation. That is a function whose second derivative minus its first derivative minus 12 times itself gives you 0. How to come up with that, right, is a topic for another day. Right, but now we can, at least now we are able to see that it is a solution. Solution to a differential equation is a function and you check by plugging it in. Okay, so Ryan already answered the challenge question. A second solution would be y equals 0. E to the negative 3x? Let's see. So that means that y prime is negative 3 e to the negative 3x, and y double prime would be 9 e to the negative 3x. So y double prime minus y prime minus 12y. So when I plug in y double prime, 9 e to the negative 3x minus negative 3 e to the negative 3x minus 12 e to the negative 3x, that does equal 0. 12 e to the negative 3x minus, good job. Another solution. Good job. There's a whole course on these, Math 204. What do you think the course is called? Math 204, Differential Equations. Yeah. But mostly we're going to stick with some simpler ones. For now, our differential equations will have the form dy dx equals some stuff with x's in it. Okay, so this was a relatively complicated differential equation. We're going to stick with some simpler ones that we have the tools to solve right now. Okay. Solving a differential equation means finding a formula of the form y equals some stuff in terms of x. Okay, so the solution to a differential equation is a function. So how would you solve the differential equation dy dx equals cosine x minus 1? Yeah, take the antiderivative or the integral, right? So I would take an antiderivative of cosine of x minus 1. What's the antiderivative of cosine x? Sine x. The antiderivative of negative 1? Minus x. And then plus c. That's a function whose derivative is cosine x minus 1. So there are infinite solutions, right? You can pick any c, and that will give you a solution to this differential equation. So all solutions differ by a constant. So if I come up with a solution and Ashley comes up with a solution and they're different, the only thing that they can be different by is a constant. We must just have different plus c's. All right, so to get a specific solution, one of the infinite many, I have to give you some other information, like an initial condition. I have to give you some information. What is the value of y at a specific x? And then we can plug in and find out what the c has to be. All right, so for example, here's a differential equation, dy dx equals cosine x minus 1. I know that all the solutions to this guy look like sine x minus x plus c. But I want the specific solution where when you plug pi in for x, you get 1 as the output. So this means that pi comma 1 has to be on the graph of the solution. So if I replace my x's with pi's, my y should be a 1. So I'm going to make my x's pi, sine of pi minus pi plus c. I should get a 1. Okay, what's the sign of pi? 0. So 1 is equal to 0 minus pi plus c. Solve for c, what do you get? 1 plus pi. So my specific solution to this differential equation with this initial condition is y equals sine x minus x. And then instead of just writing plus c, now I know a specific c. 1 plus pi. That is a function that has its derivative is cosine x minus 1, and when you plug in pi, you get 1. So this problem, where you're given a differential equation plus an extra condition, is called an initial value problem. And it will have one specific solution. Whereas if you have just a differential equation, it will have infinite solutions. Okay, so a little physics to remind you. Velocity is the derivative of, yes, displacement or position. Also, what is the derivative of what? What else is a derivative? Yeah, acceleration is the derivative of velocity. All right, so let's suppose a ball is thrown upwards from the edge of a cliff that's 100 meters off the ground. So S of 0 is 100, right? Because it's 100 meters off the ground. So at time 0, the height of the ball is 100 meters. It has an initial velocity of 74 meters per second. So that's just the speed that you throw it with upwards. So V of 0 is 74. We're going to take gravity as negative 10 meters per second squared, just because negative 10 is easier to work with than negative 9.8. So that means that A of t is negative 10 for all t. That's acceleration of gravity. So I want to derive the formulas for the object's velocity and position at any time t. And we'll figure out how fast the object is moving when it hits the ground. So I'm going to begin by writing all of the givens in terms of the position function s. So s of t is going to be some formula I don't know, right? V of t is s prime of t. Again, I don't know that formula just yet. And acceleration is the derivative of velocity, which is the derivative of position. So the velocity is s double prime. I'm sorry, acceleration is x double prime. And I'm given that this is negative 10 acceleration. All right, so if acceleration is negative 10 meters per second squared, what's velocity? Yes, you're very, very, very close. Negative 10x plus c. What's wrong with that answer? Negative 10t. Right, it's t. And yeah, you figure out what's c, which is good. But you can write plus c for now. So this would be negative 10t plus some constant c. Right, I just took an antiderivative. I know acceleration is the derivative of velocity. So if I know acceleration to get velocity, I take an antiderivative. But then I have to have the plus c there because there are an infinite number of antiderivatives. How can I figure out what that plus c is in this specific case? Yeah, because I know that v of 0 is 74. So v of 0 means that negative 10 times 0 plus c should give me 74 meters per second. Okay, so this term just goes away, and you get c is 74. So now I have v of t is negative 10t plus 74. All right, so if I now have a formula for acceleration that was given, and I have a formula for velocity. So that's one of the things I was trying to find, a formula for the object's velocity. How can I find a formula for the object's position? Take an antiderivative of velocity, yeah. So I think I'll write it down here instead of going back up to there. An antiderivative of negative 10t plus 74 would be what? Plus some constant. Yeah. So negative 5t squared, when you take the derivative of negative 5t squared, you get negative 10t. Take the derivative of 74t, you get 74. And then I add a plus c because the derivative of any constant is 0. So that would still give me the same velocity function. All right, and then to figure out what the c is, what do I use? S of 0 is 100. So I plug in a 0, and I get negative 5 times 0 squared plus 74 times 0 plus c is supposed to be 100. So c is 100. So then I plug that into my position function for c, negative 5t squared plus 74t plus 100. So those are my formulas for velocity and position of this object at any time t. All right, so if I want to figure out how fast the object is moving when it hits the ground, how fast is it moving when it hits the ground? Yeah, so first I need to know when it hits the ground, at what time, right? So which formula am I going to use to try to solve when it hits the ground? S of t, position, yeah. So when the object hits the ground, what is its position? 0. So I'm going to set S of t equal to 0. And I guess I'll use the quadratic formula. All right. Negative 74 plus the square root of negative 4 times negative 5 times 100 divided by negative 10. So I get 2.93. Oh, yeah, thank you. There we go. And that should be minus 4. Negative 1.2425, which doesn't make any sense. So it must be the, because it's plus or minus, I just did the plus. So I'll do it again with the minus. And I get 16.05. And that one doesn't make any sense, so it's got to be 16.05 seconds. So now we know when it hits the ground after about 16 seconds. How can I know how fast it's traveling when it hits the ground? Yeah, I have a velocity function, so I'll plug this into it. V of t was 74 t, no, what was it? Negative 10t plus 74. So negative 160.5 plus 74. Can everybody do that in their heads? Negative 86.5. And why did it come out negative? Because the object is falling. Yeah. So this was 16.05, right? And then I multiplied it by negative 10. So I just moved the decimal point one to the right and made it negative. Any questions on that? Okay, so I want you to think about this question for a few minutes. You can discuss with the people at your tables if you want. If the second derivative of a function is 8e to the x plus 12, and I'm giving you two initial conditions, the derivative at 0 and the function value at 0, which of these functions is f of x? All right, so the easiest thing to check here, so I have four possible functions f. And I have three criteria. Its second derivative has to be e to the x plus 12. Its first derivative at 0 has to be 4, and the function at 0 has to be 10. So the easiest one to check quickly is f of 0, right? Just plug 0 into all of the functions and eliminate any that don't give you 10. All right, so in A, if I plug in a 0, 8e to the 0 gives me 8, right? 6x squared and 4x both give me 0. Plus 10 is 18. So it's not A. Does that make sense? Okay. If I plug 0 into B, 8e to the 0 gives me 8. 6x squared and 4x give me 0. 8 plus 2 is 10. Okay, so B is a possibility because f of 0 is 10. And when I plug into C, I'm going to get 8 for the first term, 0 for the middle terms, and 8 plus 10 is 18. Can't be C. And then for D, I'm going to get 8 for the first term, 0 for the middle terms, and plus 2 is 10, so it could be D. All right, so I've eliminated A and C, so that's helpful. Because now I have to start checking derivatives, and so having eliminated 2 saves me a lot of work. I don't have to check the derivative of every function. I'll just check B and D. So for B, f prime, I should probably erase all this so that I can see it. Okay, so f prime, the derivative of 8e to the x is 8e to the x. And the derivative of 6x squared is 12x minus 4. The derivative of 2 is 0. So if I plug in a 0 into here, I should get 4, right, if this is the function. So 8e to the 0 is 8, plus 12 times 0 is 0, plus 4 is 12. Did I do that right? What? Oh, yeah. Good, thank you. Minus 4 is 4. Okay. So f prime of 0 is 4, so this is still in the running, right? Let's check D. F prime of x would be 8e to the x plus 24x minus 4. And if I plug in a 0, I get 8 minus 4, which is also 4. So that one's also still in the running. So to find out which of these two it is, I have to check the second derivative, which has to be 8e to the x plus 12. Okay, so B, f double prime is just the derivative of f prime. The derivative of 8e to the x is 8e to the x. The derivative of 12x is 12. So B has the right derivative. And D, its second derivative would be 8e to the x plus 24, which is not right. Okay, so the only one that works is B. Okay? Okay, so we've got 2 challenge problems and then some classwork. Okay. The classwork is 3 problems from your homework. I've copied them here again. But you should spend a little time looking at these challenge problems because they're not too bad and they're kind of interesting. If you want to do them last, you can. If you'd rather do the classwork and then go back, that's fine.